name is Blanche Lany. I work at the French National CERT at ANSSI, which is the National Cybersecurity Agency in France. I work there as a digital forensic investigator. I'm part of the incident response team. And most of our incidents are Windows-based, and gathering proof of execution is one of our first goals when doing incidents. And that's why I first got interested in the AmCache. And seeing the potential this artifact has, I chose to do some research about it. So what is AmCache? Originally, it was used to store metadata related to executed shim binary. So quick note about that. The shim infrastructure is a technical solution provided by Microsoft that allows a binary to run on a system it's not fully compatible with. And it's doing that by redirecting API calls to alternative code, so by applying what's called a shim. It appeared with Windows 7 and the server equivalent, so 2008 R2. We've been aware of it for quite some time. We have tools that exist to parse it. We have AmCache Parser, a tool by Eric Zimmerman, just did the keynote. We also have a Red Reaper plugin. But seeing the lack of documentation about this artifact, and I wanted to be able to better understand it. I wanted to see if anything was missing, and I wanted to better interpret the results. So for the last year and a half, I did some research. I published everything in a paper, so the link is right there. It's 57 pages long, but there's a V2 coming out today or tomorrow, and it's 66 pages long. And we'll, thank you. And we'll look at more recent versions of Windows 10. Okay, so first I'm going to talk about kind of the inner workings of the AmCache, how it works, where you can locate the information, because a lot of people know about amcache.hve or recentfilecache.bcf, but there's actually a lot more files that I consider AmCache artifact. And then I'm going to walk you through 3 scenarios inspired by a real case scenario so that you can see how you can use this artifact in your incidents. So the first scenario is called Welcome to the Hellmouth. This is the introductory scenario, so it will be quite familiar to anyone that's already used this artifact. Then we have Same Time, Same Place, which is more of a threat hunting scenario. It will look at the other files, so the XML files in the AmCache. And then the third scenario is called The Killer in Me, and it will look at drivers, because a lot of people know that AmCache stores binaries and applications, but it also stores drivers. All right, so this is going to be the brain workout part. This is the FIR fit at its best. It's going to get quite complicated, but you'll be fine. Small disclaimer before we get into this. We have several versions of the AmCache, and its behavior is dictated by DLLs, so they're under Windows System 32. They start with AE for application experience, and Microsoft had the good idea to backport them, which means that on an up-to-date Windows 7, the AmCache will behave the same as on Windows 10 up-to-date. So that's why you cannot rely on the OS version. You have to look at the DLL versions. And during this presentation, I'm going to talk about OS version, so Windows 7. It should be considered as out of the box with no update whatsoever. And it's just that it's easier to say Windows 7 than DLL version 6.1.7600. You'd agree with me? Nope. OK. So the AmCache works in, there are 2 moments where the AmCache gets updated. One, obviously, when you execute a binary. And then the second one, you have 2 scheduled tasks. One is called Program Data Updater, and it's been here since Windows 7. And the other one is called Microsoft Compatibility App Raiser. It appeared with Windows 8.1. And the way I'm going to do this is I'm going to show you through some versions of the AmCache, and I'm going to show you what happens in the first phase, and then what happens when the scheduled task gets run, when the scheduled task run. Okay, first one, Windows 7. So this is a view from Process Monitor, the sysinternals tools. This is the first phase. So this is when there's a binary that gets executed on the system. This one is called malware.exe. And as you can see, there's a process that's going to query some information about the file, and then it's going to write inside recentfilecache.bcf, and it's under Windows App Compiled Programs. This is the directory where you're going to find almost everything AmCache related. So this is the directory that you want to go look at. OK, so that's for the binary execution part. Now for the scheduled task, so you have program data updater. It's going to also query information about the file, and then it's going to write a lot of stuff inside an XML file. This one is called AEINV, so Application Experience Inventory. It's a Windows error report, even though it's not on the WR directory. Then you have a GUID, and then you have a timestamp. So be aware that the timestamp can be quite misleading. This is the first time the scheduled task ran, and then it updates the file. It doesn't write a new one with a new timestamp. So you only have one file per computer. OK, small recap for Windows 7. So binary, you want to look at recentfilecache.bcf. And then the scheduled task, which run every day. It's going to empty recentfilecache.bcf. I couldn't show that part in the process module, but it's actually going to go through every file stored in recentfilecache.bcf and then stores information about those in the XML file. OK, let's look at Windows 8. So same thing. This is the binary execution part. So once again, malware.exe. And then instead of writing inside recentfilecache.bcf, it's going to write inside amcache.hve. So this is a hive. So it's going to get loaded inside registry A, then an ID. And then it's going to create some key. So under root file, then you have a GUID that identifies the file system the file is under. And then you have an ID that represents the file. And then it's going to set some values. So you have 17, 16, A, 3. Those are really not self-explanatory. They've been explained by Yogesh Khatri in one of his blog posts. And they're also in my report so that you can have everything in one place. Second moment, the scheduled task. So program data updater, it's going to write 2 files. One of them is an XML file. It's not the same as for Windows 7. It has AMI in the file name, so that's not the same. And then second file, so propcache.bin. This will only contain driver. So if you haven't installed a driver, it's not going to fill this file. OK, small recap, because that's a lot. Binary execution, so you're going to want to look at amcache.hve. And then the scheduled task now runs every 3 days. And it's going to update amcache.hve. And it's going to update 2 files, the XML file and propcache.bin. So those are the files we're going to want to look at. OK, Windows 10 Redstone 1. In the interest of time, I'm not going to do the process monitor part again. Binary execution gets stored in amcache.hve. So that's nice. They didn't change that part. We now have 2 scheduled tasks, program data updater, which will only update amcache.hve. And then we have the new one called Microsoft Compatibility Appraiser that runs every day. And it's going to update another XML file, because apparently Microsoft loves XML file. But that's good, because it's human readable. So yay. And it's called Appraiser File Inventory. And then it's going to update the hive. OK, last one, Redstone 3. Nope, yeah. This is just to show you that they changed the format of amcache.hve. So it's now under root inventory application file instead of root file. And it has the file name of the binary that was executed. And then the values are called program ID, file ID, lowercase long path. So they're easier to understand. That's good for us. Last recap, binary execution. You want to look at amcache.hve. Program data updater doesn't seem to do anything amcache related in this version. And Microsoft Compatibility Appraiser just updates amcache.hve. So no XML file. Yeah. OK. That was the hard part of the presentation. Thanks. If you managed to follow me, welcome to my world. This is the AmCache, and this is me. If you're kind of lost, don't worry, I have this table for you. This is a summary of every file we're going to want to look at, and then we have information that we, as forensic investigator, are interested in. So we have file name, file path, and SHA-1. Those relate to the binary that was executed. Then we have program. So this is an application that got installed on the computer. So you double-click on setup.exe, or you installed something from the Windows Store, and then you have an install registry key. You have files under program files. So this is what I mean by program. Then you have install directory. So what I mean by that is the list of every binary that are under C program files and then a program name. So it's related to program. And this is because it will be more clear in the second scenario, but this is because it's a really nice hiding place for an attacker. Then we have driver, and then we have driver path. So this table will be updated as we go through the scenario. OK, first scenario, welcome to the Hellmouth. Once again, this is an introductory scenario. So it will look at how you may use this artifact in like 80% of the time. So this is, there was an attacker that compromises a user account. It's on a Windows 8 machine. He logs on as this user, and then he launches malware.exe. And then he deletes the file. So we are being called on this incident because there was a suspicious behavior identified on this machine. We found several artifacts that indicate the execution of malware.exe. So we found prefetch, we found app-compat cache, we found user assist. But the file is no longer on the system. So that's a bummer for us, because we cannot give it to our reverse engineering team. We don't have any IOC to look for. So that's a bummer. But it's a Windows 8 machine. So let's look at AmCache.hve. This is what it looks like. This is a view from Regedit. Just be aware that I mounted the Hive manually. It's not going to be there by default. And so we're looking under root file, then the GUID that represents the file system, and then the ID for malware.exe. And we have a lot of values. We have 15, which is the full path of the binary that was executed. So that's a nice way to find the registry key. And then we have 101, which is the SHA-1 of the binary that was executed. So that's nice. And it's preceded by 4 zeros. And I don't know why Microsoft does that, but it's consistently done every time there's a SHA-1 in the AmCache. So you always have 4 zeros before the SHA-1. And by retrieving this information, you can, for instance, go look at your MISP instance. If anyone has ever seen this malware, you can look at VT if you're allowed to go on the internet. You can even look at some other source of known bad lists. And if you're sure it's a malware, and not just because it's called malware.exe, but if you're sure it's malicious, then you can use this SHA-1 to do some threat hunting on the rest of the information system in case the attacker just moved to another computer. OK, so let's update our table. File name, file path, and SHA-1. You can find this information in every version of AmCache.hve, whether it's Windows 8 or Redstone 3. But the Windows 7 column looks kind of sad. It doesn't have any crosses in it. But since you can still find Windows 7 computers during incident response, let's look at where this information is located and how it works. So this is a view from recentfilecache.bcf. This is a binary file. It can be parsed with my favorite tool, which is strings. Yeah, it's a great tool. Strings.-ael, because it's UTF-16 Little Endian. And you have the full path of the binary that was executed. But that's the only thing you have. You don't have the SHA-1. And, well, you don't have the SHA-1. And you don't have the rest of the values associated with the file. Also, you have some weird exceptions on whether it's referenced in recentfilecache.bcf. those are weird. They're explained in my reports. I don't really have time to go into it right now. And final limits, the content of recent-cache.bcf gets emptied every day by the scheduled task. So this information is lost, but program data updater updates an XML file. And this is what it looks like. So the part that's interesting to us is program list. So it has two lists, installed, which is going to reference every installed application on your system. And then you have orphan for binaries that were executed but weren't part of a program. So kind of a standalone binary. And malware.exe is not part of a program, so it will be under orphan. And this is what you'll find. So you have the file name, and you have the ID, which is the SHA-1, still preceded by 4 zeros. But you don't have the full path, but that's still good information. So once again, let's update our table. File name, file path, you can find that in recent-cache.bcf. Although be aware it gets emptied every day. And then both XML file from Windows 7 and Windows 8 stores file name and SHA-1. OK, so that's it for our first scenario. Let's look at the second one, same time, same place. So this is the threat hunting scenario, and it will look at how you can use the XML file to get more information and to move forward your threat hunting. So you have an attacker that compromises a user account. It's on a Windows 7 because we want to look at XML files. And the nice thing about Windows 7 is that even though it's updated and the AmCache behaves as Windows 10, it will not delete the other files. So they will still be here on the system. And so the attacker hides a malicious binary called hiddenmalware.exe because he lacks imagination. And he hides it under 7-zip. So obviously 7-zip is installed on the system. He doesn't even execute it. He's just hiding it inside this directory. OK, so you're an analyst. You're being called to do some threat hunting on the machine. You don't have any specific lead. And since it's threat hunting and not incident response, we're going to look at the XML file and not recent-cache.bcf. So just a heads up, this part we're going to look at some intricate details about the XML file. It gets kind of complicated. So this is what it looks like. We have a new list called updated. Let's see how it works. So in the XML file, programs are defined by 6 different indicators. So they're run keys, uninstall keys, these kind of things. Then you have directory indicators. This is the one that's going to be interesting to us. This is the list of the program files directory, and then every subdirectory that contains exe files. If you have any change in one of the indicators, then you're going to have an entry in the updated list. So updated doesn't mean you changed version of you changed the version of the program. This means an install of the program and then a reinstall of the new version. Updated means one of these indicators changed. And in my experience, that doesn't happen often. Like, that never happens. So to get back to our scenario, when the user installed 7-zip, an entry was created in installed. And this entry contains the path to program file 7-zip, and then the list of every binary, so exe and DLL, that are under this directory. And then when the attacker came on the system and put the new binary inside 7-zip, the directory indicators changed, so you have an entry in updated. And in this entry, you still have the list of every binary located under program file 7-zip. So this is what it looks like. This is the view from the updated list. You have directory indicators. Trust me on this. It's program file 7-zip. This is Microsoft. And then you have static properties, which contains the list of every binary. So by taking this list, and by taking the one from installed, and by doing a differential analysis between the two of them, then you get this file. So you have hidden malware.exe, the file name. Then you have it's SHA-1. So that's a great thing to do that doesn't cost much and that can really move forward your threat hunting. And it doesn't, I mean, in my experience, I never got a false positive with that. So that's a good one. OK, so let's update our table. Program information, you get that in AmCache or HVE, and you get that in both XML file from Windows 7 and Windows 8. But the list of every binary, you only get that in Windows 7. It's no longer in Windows 8, in the XML file from Windows 8. That information was lost in this version. But good news, Windows 10, because they changed things a lot. The XML file doesn't exist, but you have a new scheduled task. You have Microsoft Compatibility Appraiser, and it updates a file called file inventory. This is what you want to look at. The way it works is that you have a bunch of scan paths, and it's going to scan those directories to list every binary under those, whether it was executed or not. So you have program files, and you have program files x86. And this is what you'll find. So you have hidden malware.exe, the file name, and you have the full path. You don't have the SHA-1. So that's sad. And you cannot do the differential analysis. But once again, they change things all the time. So in Redstone 3, inside AmCache or HVE, those directories are actually scanned along with every user's desktop. And the binary that are under those directories, they're going to be put in AmCache or HVE, along with the SHA-1. So you have the list of every binaries and the SHA-1. That's great. But be aware, they might not have been executed. OK, so let's update our table. So Appraiser file inventory contains file name and file path, and half of the information that's interested in the install directory. But Redstone 3 contains the install directory. OK, final scenario, the killer in me. So once again, this will look at driver information, and this is, this will look at driver information. So we have an attacker that compromises a Windows 10 account, Windows 10 machine, sorry. He's going to use a legitimate but vulnerable driver, which is called vboxdrb.sys. This is a driver that's been vulnerable since 2008, and it's vulnerable to a remote code execution, and it's actually being used by some real threat actors. And he's using it so that he can have a backdoor in case he ever loses his privilege, so that he can regain them. So you're an analyst. You're being called on this incident. You have done the immediate response, and you want to know if the attacker left anything else. So it's a Windows 10 machine. Let's look at AmCache.HVE. We have a new key that's called inventory driver binary, and it's going to invent our drivers. The key name is the full path of the driver, and then you have the driver ID, which is the SHA-1 of the driver, still preceded by 4 zeros. So by retrieving only this one file, you have the list of every driver installed on the system, along with the SHA-1 for those drivers. I mean, that's useful information. And you can even compare this list to a list of non-good lists. I know people run SIGCheck, so you can have a list of non-good lists, a list of non-good drivers, sorry. You can also have a list of non-bad. This one is actually on VT, so this would be a thing to look at if you're doing an incident on this case. This information can be found inside Redstone 1 AmCache HVE and Redstone 3. This wasn't there for Windows 8. So that's sad, but we have XML files, and we have binary files. So let's look at the XML file, AE-INV AMI. This is what it looks like. You have a new list called driver list, and it's going to list drivers. Shocker. And in there, you'll find vboxdrb.sys. and then you'll find the SHA-1. Oop. Okay. Then you have the SHA-1 for the driver. You don't have the full path, but I mean, you can still use it to help with your triage. And you have another file called propcache.bin. This is a binary file. Once again, strings is your friend. You have the driver path, you have the driver file name, and you have its SHA-1. And the way this file is laid out, so you have a directory, and then you have the list of every driver inside this directory. So right above that, you have C Windows System32 drivers. So you'd know the full path for the driver. Okay, so final update for this table. Driver information can be found in Windows 8. And that's the funny thing about this artifact. Every time, almost every time it adds information in AmCache.hve, it was previously there in an XML file. That's why you want to look at every file. That's why you want to look at every file. You don't want to miss important information. This is my conclusion. This is an artifact that's difficult to analyze. You have to check the DLL version. You cannot rely on the OS version. That's the important part for this presentation. You want to retrieve all the files. You don't want to miss any information. You don't want to miss SHA-1s for the drivers. That's cool. You have to be careful with your findings. It's not because a binary is inside this artifact that it's been executed. You want to be careful about the date of execution, because I see a lot of people think that every time the last modified registry timestamp is the date of execution. It's not true every time, especially in Windows 8. In Windows 10, it starts getting better, so you can rely on those more. And then, as often in forensic, it's not because the binary is not inside this artifact that it was never there on the system. That's not a thing you can say with this artifact. And it's even more true in Windows 10 because for some reason, starting with Redstone 3, it stopped putting non-GUI binary inside the AmCache. That's sad. But this artifact is still a precious asset in an investigation, and it's even more true as time goes by, because so the AmCache stores executed binaries. It stores binary that are present on the system. It stores application. It stores drivers. But it also stores information about the OS, information about sensors, information about USB devices that were plugged in, information about Office version, Office add-ons. At this point, I'm pretty sure that Microsoft, it has a switch case for information to store, and then AmCache is like default. So then it just gets put in this artifact. And that's why you want to still study this artifact. And so there's a link to my paper to help your analysis for this artifact. And that's it for my presentation. And if you have any questions, I'd be happy to answer it. Thank you.